So for start, let's create a new Azure IoT solution using Visual Studio Code. So first, let's give it a name, call it the Energy Grid Demand Forecast. And we will select a Python module since we are using the Python environment. And with that, we just give the module name, predictor, and we'll point it to a local container image first. So this code generator has really created some scaffolding structure for your module development and deployment. So we won't be diving into the Docker explanation. So as you can see the module predictor with the Docker file and the main Python file. So in the main Python file, we will utilize the Azure IoT SDK in the code base. So such as the IoT module create client from the edge environment. And the important functions are the create client method, which we are running through right now, as well as the run sample code. So the create client simply just instantiate the client with the edge module and operates a message handler. And another next important part is the run sample code, where we will customize the needs of our modules as explained in the slide before. So for now, just briefly understand the different parts of the code structure, and later we'll be replacing these with what we have developed for our use case. So if you remember clearly, we have mentioned about the deployment configuration file. So first we have the Edge Hub that acts as a local proxy for the IoT Hub by exposing the same protocol endpoints as IoT Hub. So this consistency means that the client can connect to IoT Edge runtime just as they would with the IoT Hub. So the Edge agent is responsible for instantiating modules, ensuring that they continue to run and report the status of the modules back to the IoT hub. So we can see that the system modules are pointing from an image location that is stored as a public Docker image from Microsoft, which serves as a standard module that manages Edge processes. So here we further drill down into different modules we have developed. So later on, we'll build this configurator file so that we can use for the deployment to the IoT Edge runtime. So the Visual Studio Code also provides a nice extension to the IoT Hub. Let's select our IoT Hub. We will select the Energy Grid demo. Prior to this demo, we have simply created an IoT Hub with the IoT Edge device. So for more information, please refer to the blog. So if we look into the Azure portal, you should see the device have been created in the IoT Hub. And by default, the two system modules have already been deployed, and with an IoT Edge runtime response of 200. And for our use case, we have already developed and prepared a Git repo for this. So let's download this Git repo and we will replace the contents in our development folder. Let's delete the existing module in the development folder, and we just simply replace the two modules inside this modules folder. So going back to the code base, in the predictor module under the app folder, you will see the Flask application in there as well as the model that's in the neural network folder. So during Alicia's model development deep dive, you should already understood how the Python code works. So for now, in the predict handler method, the results of the demand forecast will be sent as a JSON format back to the transporter module defined in the main Python file. So the transporter module will be covered in the later deep dives. What we will need to do is to right click the deployment template and we will build the IoT solution. And basically what it does is that a deployment manifest will be generated in the config folder. So if you open up the deployment manifest here, you will see the various definitions. So important to note is the image that's pointing to the modules is pointing using the Azure Container Registry, which is simply like a Docker Hub that is stored in the Azure environment. So you can see the different modules are actually pointing to the image that is residing in ACR. Once the module development is completed, we will then build it into a Docker container image and push it into the container registry ACR for this case. So all we have to do is just to run this command line to trigger the Docker build operation. So once the predictor module is pushed, we will do the same for the transporter module as well. So if you look into the Azure portal of the ACR service, you can see that the containers have already been pushed in before in the repositories section. So to deploy into the Azure IoT device, all you have to do in Visual Studio Code is to right-click and to select Create Deployment for Single Devices. And we'll select the deployment manifest file. So once succeeded, we can verify through the Azure portal that the modules have been deployed successfully. So first is to see the IoT runtime response showing 200 OK. And we go into one of the logs, it will state that it's actually waiting for any incoming messages from the provider, which in the later steps, or rather in the later sections of the deep dives, in the C2E and E2C communication, we'll be elaborating more of it.